At the end of the topic, you will be able to
state the principle of a screw gauge, detail the construction of a screw gauge, describe the components of a screw gauge, and discuss the types of errors and their corrections.
measure the diameter of a thin wire using screw gauge.
In order to measure anything, first we must choose an appropriate measuring instrument. To measure the length of a stick, we can easily do so using a tape or a meter rule. But if we have to measure the thickness of the stick, then we prefer to use either the scale or the vernier caliper or the micrometer screw gauge. Of all the measurements made, we can realize that the scale gives the least accurate measurements, and the most accurate measurement is that of the screw gauge. Let's know more about the micrometer screw gauge. A screw is a simple machine. It has many uses. Screws are used in fixing parts of a machine and in screw jacks to lift or to support loads, etc. The main parts of the screw are the head and the thread. The head of the screw allows the turning instrument to fit in. The threads in the screw make it rotate and advance through a fixed nut which has similar threads inside it. Thus, the screw advances to a distance in proportion to the rotation of the screw. This principle is used in the working of a screw gauge. The distance travelled by the tip of the screw for one complete rotation is called the pitch of the screw, which is normally the distance between the two consecutive threads on the screw thread. To determine the pitch of the screw is rotated, say, n number of times, and the distance moved by the screw is noted at, say, x. Then, the pitch of the screw P is equal to x divided by n. When the screw is rotated to some fractional distance, the screw also travels the same fractional distance ahead. To note down this fractional distance, the head of the screw is divided into n divisions called head scale. Thus, the distance travelled by the screw is equal to its pitch only when all the n divisions of the head scale cross a reference line. When only one of the divisions of the head scale crosses the reference line, the screw travels a least distance. This least distance travelled by the screw is called the least count. Thus, least count is equal to the pitch of the screw divided by the number of head scale divisions. If the pitch of the screw is P and the number of head scale divisions is N, then the least count, LC, is equal to P divided by N. A screw gauge works on the principle of a screw and a nut. The screw is flat at one end, S2, called spindle, which is exactly parallel to another fixed end on the metal frame of the screw gauge, S1, called the anvil. This screw moves inside a nut, which is a hollow cylinder C, which is also called the thimble, and has the fine threads inside it. The screw gauge is made of a U-shaped metal frame, which has a fixed end S1, or anvil, at one end and the cylinder at the other end. The surface of the cylinder has an index line with many divisions of 1 mm or 0.5 mm, which serve as a pitch scale P, or the main scale of the screw gauge. The screw runs within the cylinder. The flat tip of the screw is S2, and the other end of the screw, a barrel with milled head, is attached. The other end of the barrel is tapered, which is divided into 100 equal divisions that serves as the head scale or the circular scale. With the rotation of the cylinder, the screw also rotates, and both the cylinder and screw can move back and forth axially. When S1 and S2 are in contact with each other, the zero of the head scale coincides with the index line of the pitch scale. There is ratchet close to the milled head of the barrel, which avoids excessive pressure on the object held between S1 and S2. There are two types of errors based on the location of the 0th division of the head scale of the screw gauge. They are negative zero error and positive zero error. If the 0th division of the head scale is above the index line, the error is negative. This error can be corrected by adding the observed head scale reading to the number of the head scale divisions that coincide with the index line. If the 0th division of the head scale is below the index line, the error is positive. This error can be corrected by subtracting the number of head scale divisions that coincide with the index line from the observed head scale reading.
Accurate measurement of small distances by instruments such as screw gauge is a skill. When using screw gauge, follow these steps in order to avoid errors in measurements. Determine the pitch of the screw, determine the least count, and then measure the diameter of the given object, considering the zero error in the instrument. Let's take an example to learn these procedures. Here is a thin wire for which we can determine the diameter using a screw gauge.
First, let us find the pitch of the screw in the screw gauge. To determine the pitch of the screw is rotated, say, n number of times, and the distance moved by the screw is noted as, say, x. Then, the pitch of the screw P is equal to x divided by n. Note the initial reading on the pitch scale. After 3 complete rotations of the screw head, note down the pitch scale reading again. For 3 complete rotations of the screw, it has travelled a distance of 3 mm. We find that the pitch of the screw is 3 mm divided by 3, which is equal to 1 mm. Thus, the distance between 2 threads of a screw is 1 mm. Remember that least count is equal to the pitch of the screw divided by the number of head scale division. This screw gauge has a pitch of 1 mm. Now let's check the divisions in the head scale. It has 100 divisions. Therefore, the least count of this screw gauge is 1 by 100, which is equal to 0. Let us now check for the zero error of the screw gauge. To do this, rotate the ratchet till the end of the screw comes in contact with the stud. Now, check the location of the 0th division of the head scale of the screw gauge. The 0th division of the head scale or the circular scale is below the index line of the main scale. Thus, the error is positive and the correction required is negative. In this screw gauge, observe that the 5th division coincides with the index line on the head scale. Thus, zero error is 5 and the correction required is -5. Thus, measurements made using the screw gauge require correction of -0.05 mm, 0.1 mm.
Let's now measure the diameter of the wire using the screw gauge. First, carefully place the wire between the stud S1 and the end of the screw S2 by rotating the ratchet. Stop when the ratchet slips without moving, holding the object tight. Once you have placed the wire firmly, note the reading in the pitch scale. Call the pitch scale reading PSR. Note the number of divisions on the head scale of the circular scale that coincides with the index line. This reading is the head scale reading HSR. Here the pitch scale reads 0 and the head scale reads 57. To find the corrected head scale reading CHSR, subtract the zero error from the observed head scale reading HSR. Here the screw gauge has positive zero error 5. Therefore, subtract 5 from the observed head scale reading of 57 gives the corrected head scale reading 52. To find the diameter of a wire, multiply the corrected head scale reading CHSR with least count LC and add it to the main scale reading MSR. Thus, we have D, the diameter of the wire, is equal to PSR plus CHSR into LC, where PSR is pitch scale reading, CHSR is corrected head scale reading, and LC is least count. Thus we find that the diameter of the wire is D is equal to 0 plus 52 into 0.01 is equal to 0.52 mm. In order to avoid any errors in positioning or reading, it is better to repeat the measurement a few times. Then enter the readings into the table as shown here and find the average of the readings, which will give the most accurate measurement.
In this topic, you have learned a screw gauge works on the principle of a screw, which advances to a distance proportional to the number of rotations of its head. The distance traveled by the tip of a screw for one complete rotation of its head is called the pitch of the screw. The least distance traveled by the screw in a screw gauge is called the least count of the screw gauge. The screw gauge consists of a pitch scale and head scale divisions that enable it to measure the thickness of objects. There are two types of errors, namely positive zero error and negative zero error, based on the location of the zeroth division of the head scale of the screw gauge.